Okay, so hey everybody, my name is Arden Khandelwal, and today I'll be showcasing the first Headstarter project for me, which is based upon market anomaly detection. So this week we were tasked by building a project which mainly classifies all the possible anomalies within the market system by giving us a particular CSV file and then detecting any anomalies that can occur. So just to give you a brief overview of exactly what happens, in today's market is in respect with all the indexes and stock market fluctuations and various other things, there are a lot of anomalies that can occur. And by anomalies, I mean crashes and no crashes perhaps within the market, right? In order to mitigate these particular anomalies that could potentially occur in the future, what we could do is build a machine learning model which can easily detect these anomalies that can occur in the near future. Through this, you can easily classify the market conditions and also propose any investment strategies for any risk mitigation, perhaps. Right. Through this project, we were tasked with having three milestones completed. First one, of course, developing the anomaly detection model. Second one, perhaps an investment strategy, which is data driven, and third one, building an AI driven bot, right? Due to the lack of time given to me this week, due to the lack of time that I had this week, I was unable to complete all the milestones that were present through this project. However, I have completed milestone one and partially milestone two as well, and I'll be showcasing that right now via this code. So through this code, you can see that this is in the Python format. So over here, you can see that I've imported all the libraries that are really present. So I have imported pandas, numpy, seaborn, and of course sklearn as well, particularly for the machine learning aspect, right? So the first step was, of course, data loading and cleaning. So the first step is basically to just load the financial market data set, which was given to me, and that's given right over here, which is the financial market data.csv. So over here, we had a lot of historical data with multiple figures, features, and a target variable, which is called as y. So you can see a particular variable over here, which is known as y, and it is in a binary format. So every single time when y is equal to 0, that represents no market crash or no anomaly. And whenever y is equal to 1, that indicates that there is a market crash or there is an anomaly that could happen, right? So for this particular thing, what I did was that once the data set is loaded, we clean it and we convert the data column into a date time format, right? Which helps us for proper time series handling. And we also check for any missing values to ensure that the data is clean. So you can directly see over here that the data is directly formatted into date time format, which helps us into directly reading the entire data with ease and much more efficiency, right? Then moreover, you can also see that the next step was all about visualizing the time series data. So what happens over here is that we now start to visualize the data in trends and the anomalies that occur over time, right? So for this particular thing, what we did was that for each feature in the dataset, we created a time series plot bar. So over here, you can see that the figure and fixed size, you can see that I've created bars which represent data, right? And particularly, I've also given over here the time series column with date as well, right? So essentially over here, green bars represent y is equal to 0, which means that there has been no market crash, while red bars means that there has been a market crash. And to give you an overview, you can directly see over here for particular indexes that has been done, such as DXY, you can see that the x-axis represents the date in years, of course, with an interval of 4 years from 2000s, and the y value indicates the index value that has been occurring over time. So you can see that the number of anomalies that have occurred around the period of 2009, which was known for the financial crisis, can be directly seen, and you can also zoom into that with the particular um, uh, what we say metrics given over on the right as well. And you can also further see that whatever is happening with with Japan's index as well, and and the Great British Pound as well, and various other indexes, everything is directly given over here with all the data that has been provided via the CSV file. Moving on to our third step, which is all about feature engineering and rolling statistics. So basically, to enhance the data set, what I did was that I calculated rolling statistics for each feature, and in this case, we basically do a 7-day rolling window to compute the rolling mean. All right, and what I mean by that is that because rolling statistics basically help just to capture the short-term trends and volatility in the data, and it overall helps in boosting the performance of machine learning models. So over here, I converted everything into a rolling mean type of data set, and everything is now completed with a rolling mean particular data set provided within the first few rows, right? So you can see that for all these particular indexes, I have provided the rolling mean data. And like I've just done it for the first five, like due to the df.head particular command. But this is what it really looks like, right? And then moving on to the next step, which involves all about model training and evaluation. So that was mainly where I took on three particular machine learning models, which is decision tree, random forest, and the gradient boost classifier, right? So these models are basically just trained to predict the target variable, and which indicates that whether a market crash will occur or not. And the dataset is now split into various training and testing sets, and each and every single model, which is this model, is then evaluated on various metrics. These metrics are basically universal, and they're known as F1 recall, precision, accuracy, and the CV score. I've also included their formulas over here so that it can easily be evaluated. Upon amending and upon getting these particular information, we can then test and we can then figure out which particular model yields the best output for all the data set that is present within the rolling mean data set. So if you can go down over here, you can see that the model performance comparison clearly scores that the score is given on the y-axis, the decision tree, the random forest, and the gradient boost. So with all the metrics given over here, you can see that the test accuracy for the random forest model is pretty high, while the recall for decision tree is not that great. So all of these particular metrics are to be considered and further evaluated upon so that we can develop a proper systematic model for market anomaly detection, right? And just to quickly summarize exactly what I've done through this project in 4 steps, basically. My first step was load and clean the financial market data. Second was directly visualize the patterns and anomalies to understand the overall market behavior, which is provided in the CSV dataset. My third step was engineer any new features like rolling statistics to enhance the data set. And my fourth main step was all about how to train and evaluate machine learning models to predict these market crashes. Um, this has provided a solid foundation on how to further build this particular detection model. Although there were several challenges which I really faced over the course of doing this project, I really hope to enhance this and maybe complete all of the milestones that are present within this, especially with the AI driven bot that has been given, and hopefully make it into a robust model. Thank you, and that's all from my side.